Hi, welcome back. Today we're going to look at inverse trigonometric functions. Now remember, if a function has an inverse, we have to first make sure it is 1 to 1. Remember, every x corresponds with one y to be a function, but to have an inverse, every y must correspond with one x. So whenever we have trigonometric functions, we will need to restrict the domain of the function. So looking over here at sine, well, we could see that if we kept going, we use the whole function, it wouldn't be 1 to 1, right? We wouldn't pass that horizontal line test. So we're going to restrict the domain of the sine function to negative pi over 2 to pi over 2. Now, just quick things about how to say inverse sine functions. So there's two ways that you'll often see it written. You'll either see arc sine of x, which is, you could say, when you see this, it's y is equal to the arc sine of x. Or you can see with that -1 exponent, right, which is the inverse symbol, and we could say y is equal to the inverse sine of x. Now remember, sine is the opposite of a hypotenuse, or in the unit circle is the y over the r. So the sine of the angle would always equal that ratio. Now when we're looking at the inverse, remember the x and the y swap places. The input becomes the output becomes the input. So here we're going, whenever we're using inverse sine or inverse functions, the arc sine of the ratio is going to equal the angle. So this is when we have the ratio and we want to find that angle. And you can use that in your calculator. You just hit second sine. So on this table, we have the y values here, which were originally our x's. So instead of having values from 0 to 2 pi, remember we restricted the domain from negative pi over 2 to pi over 2. And so at negative pi over 2, the y value is equal to 1. But remember, now we're flip-flopping this, so we have this, that for arc sine, that will be our domain. That'll be our values that we have for our domain. So you can see right here on the graph, this graph is restricted here, and here's the lowest point, right? The minimum, relative minimum, absolute, really there's nothing else there because we restricted it. So -1, -1, negative pi over 2 is going to be the lowest point. And then you can see over here, 1 to pi over 2. So we have these extrema, and you can see that the domain has switched with the range for sine and arc sine. All right, just a basic summary of how we restrict the domains of the inverse functions to find those inverse functions. So the arc sine is going to have a domain of -1 to 1 because that's usually how the sine function, the range of the sine function. Same as the range of the cosine function, right? They both go up to 1 and down to -1. So that becomes the domain of the inverse function. Now the range is the restriction that we put on the domain in the beginning. So we restricted this domain from negative pi over 2 to pi over 2. So this is this will be the range for the inverse sine. Now looking at cosine, the same thing will happen with the domain. It's still -1 to 1 because you can see that this function cosine is going to be between -1 to 1 for its range. So that becomes the domain of arc cosine. We're going to restrict the domain of cosine from 0 to pi. So you can see that these values over here are going to correspond. So you have -1 pi, and then we're going to have 1, 0. Now let's look at tangent. So the original function, tangent, has a range of all real numbers. So that will become the domain of the arctangent, of the inverse tangent. And we're also going to restrict this domain so that we only have a function that is 1 to 1. So we're just going to restrict it with these first asymptotes that we've talked about in previous lessons. So from negative pi over 2 to pi over 2. Now what I like to do, particularly with remembering these restrictions, is to think about them in the quadrants. So when we have negative pi over 2, that's going to take us down in the fourth quadrant. So we can use any of these angles in the fourth quadrant, and then any of the angles up here in the first quadrant for sine. For cosine, we're going from 0 to pi, so you're only looking at angles in the first and second quadrant. So we're going from 0 to pi, so only this area, so only quadrants 1 and 2 are going to be the values that we use for the range of inverse cosine. Now arctangent is similar to arcsine, but remember we don't go all the way to negative pi over 2 because that is an asymptote. So we're going to use all the values, not including these quartiles, of quadrant 1 and quadrant 4. Okay, now let's evaluate these. So remember, for each of these, we're looking for the angle. So it might be helpful to say, all right, well, this is going to be the angle. So what's going to be the sine of the angle when the ratio is root 2 over 2? So just remember, we're looking at only specific quadrants. In general, whenever it's positive, we'll be in the first quadrant, which is helpful. So remember, when we have an angle with a ratio of root 2 over 2, that's going to be a 45, 45, 90. And you can remember that from your unit circle. So the sine, or that angle, will equal pi over 4. And remember, we're only going to have one answer because it has to be the inverse function. Okay, let's go to the inverse sine of negative root 3 over 2. So this one, make sure we look at the negative. So this will take us into the fourth quadrant. Remember, sine we're only using quadrant 1 and quadrant 4. And so negative root 3 over 2, well, we know that's going to be a 30, 60, 90. So this would be negative root 3, and this is 2. And we always know the 60 degree, or the pi over 3, is opposite of root 3, and it's in the fourth quadrant, so this will be negative pi over 3. Now let's look at arcsine of 2. Well, it looks like it's going to be an easy problem, but just be careful because it's a trick. All right, so just going back, and this is, sorry if this is making you dizzy. So we said that the domain of arcsine can only be between -1 and 1. So if you have a number that's higher than 1 or lower than -1, it will not work. Okay, it's a value that is not in the domain. So it actually ends up being a lot easier. Not possible. And we can say it's not in the domain. All right, let's look at the inverse cosine of negative root 2 over 2. Well, by now you already know negative root 2 over 2 is going to be that 45 or that pi over 4. But the tricky part on this problem is just figure out which quadrant it's negative. So that's going to take us into the second quadrant. Remember, cosine is just using 1 and 2. Again, this is the pi over 4 reference angle, but the rotation is going to be 3 pi over 4. So this angle is 3 pi over 4. Remember, we have a range for arc cosine from 0 to pi. Okay, arc cosine or inverse cosine of 0. Not too bad. We could figure that out pretty quickly. We're trying to find that angle, and we know that the cosine, or the x, is going to equal 0 at pi over 2. So whenever right here, this on the unit circle, that's when we have that coordinate 0, 1, right? So that's when arc cosine equals 0, or that angle equals 0. Okay, now let's look at the tangent or the inverse tangent of -1. Again, it's not too tricky. We already know that's a 45-45. That's going to be congruent sides. It's just making sure this is in the fourth quadrant. Okay, the restrictions with inverse functions. So again, that's going to be a pi/4 reference angle. It's a negative rotation. So we can simplify that to equal -pi/4. Now let's go back to right triangles here. So we have two sides here. We have the angle, and then we have the opposite and the hypotenuse. So we know we can write that as sine of theta equals 10/x. Now we want to write this with the inverse function. So we just take the inverse of both sides. So we'll have arc sine, or you can write inverse sine of 10/x. So we could also write it, like I said, as inverse sine 10/x. Okay, let's look at the next triangle. We have the angle here, we have the opposite, and we have the adjacent. You know right away that's going to be tangent. So the tangent of theta will equal x plus 5 over x minus 1. So theta will equal arc tangent of x plus 5 over x minus 1. So we're writing the relationship, this little function, as a function of x. Okay, for this problem we want to just discuss a little, I know it's a video, but the difference between arc sine of 1/2 equals x and sine of 1/2 equals x. So remember, and I'm going to spell this out, this is the ratio. And this is, if I was going to rewrite it with a sign, we'd say sine of x equals 1/2. And we actually can solve that, right? So that would just give us a 30, 60, 90. So we know that that would be pi/6. So we could solve that. So x here would be pi/6. So arc sine of 1/2 is giving us the ratio. We're solving for the angle. Versus the next one, sine of 1/2 equals x. Remember, this is the angle. And we're solving for the ratio. So if I was going to draw a picture, well, it'd be pretty narrow, but this angle would be 0.5 or 1/2. And then we find the ratio of those two sides of opposite over hypotenuse. So we're on this one, we're actually we're solving for the ratio, or evaluate, because you're really just simplifying it. All right, so just a little different, and you can tell with the pictures, they're completely different angles. Okay, whenever we have trigonometric functions, we can combine them. So we can actually combine them as well with inverse functions. So when I was talking about taking the opposite, taking the inverse sine of both sides, essentially they're opposite operations. Okay, so the sine of arc sine of x simplifies, those cancel each other out to x. The arc sine of y, those cancel out and you get y. And that happens as well with cosine and arc cosine, tangent and arc tangent. There is one major thing you need to make sure you consider, and that is the domain. So remember, just like compositions of functions, we worked inside then out. So you want to make sure that you simplify what's ever inside first, and make sure that x, this value here, for sine, for arc sine and arc cosine, that value needs to be between -1 and 1. Now, arctangent does not have a restriction on its domain. So that can be all real numbers. But just be careful, because when you're simplifying that and you're using this way, maybe find the sine of the angle and then you want to find the arc sine, make sure the angle, this output, and I'll use a different color because this is equally important, this angle right here needs to fall within the restriction that we had for the original trig function. So remember, arc sine is restricted to quadrants 1 and 4, negative pi over 2 to pi over 2. Arc cosine is restricted to quadrants 1 and 2 from 0 to pi. And then arc tangent is restricted to quadrants 1 and 4, not including negative pi over 2, but in between those values and pi over 2 because of the asymptotes. Okay, let's find and evaluate these problems. So for each of these, I'm going to make sure that we double check with the domain and the range whenever appropriate. So arc sine, remember this domain needs to be restricted from -1 to 1. So that 0.7 is definitely between -1 and 1. Sine and arc sine will cancel each other out, so that equals 0.7. Looking at arc cosine of pi over 2, well, cosine of pi over 2 is definitely okay because when we use arc cosine, when we evaluate in quadrants 1 and 2 from 0 to pi. So this value is between 0 and pi. Arc cosine and cosine will cancel out, so we'll just have pi over 2. Now let's look at sine of 7 pi over 6. Sine of 7 pi over 6 we could definitely find out. So that's going to be in the third quadrant, has a reference angle of pi over 6. And if I sketch it out, not a great sketch, but the sine value would be -1/2. So this simplifies into arc sine of -1/2. Now be careful because if you remember, arc sine was restricted to quadrants 1 and 2. So remember, if we want to find the rotation or the angle when the ratio is -1 over 2, I meant to write, that would take us into the second quadrant. It's still going to have that same reference angle of pi over 6, but it's going to be negative pi over 6. So this is going to simplify to equal negative pi over 6, which is really confusing because you had a different input. So you plugged in the 7 pi over 6. Sine of 7 pi over 6 is -1/2. We're simplifying inside those parentheses. And then arc sine of -1/2, we have to consider the domain of the inverse function. So our output is going to be negative pi over 6. Same reference angle, but a little confusing. So here we have arc tangent of -14. Well, it seems like a weird number, but arc tangent does not have a restriction on its domain. Remember, it will go from -infinity to infinity. So -14 actually works just fine. So tangent and arctangent cancel each other out, and we are left with -14. Now let's look at arc cosine of pi. Arc cosine of pi, do you remember this value for x? Remember, it has to be between -1 and 1. So this is not going to work. Pi is obviously bigger than 1. It's 3.14, keeps going. So this is not going to be possible. Right? With this next one, let's just be careful because tangent of 5 pi over 4 takes us into the third quadrant. So we know that with all students take calculus that this will be a positive value. So we know that this is pi over 4 reference angle, and this will equal 1. So the arctangent of 1 needs to actually be in the first quadrant. Okay, so just be careful because this arctangent or the inverse tangent is restricted to the first and fourth quadrants. So it still has a reference angle pi over 4 that we saw over here. So this answer in the first quadrant will be positive pi over 4. Okay, let's go to some more practice problems. So for each of these, I'm actually going to draw them out because it might be easier to think about them as triangles. Okay, we're solving for the angle here, and then we're going to find the ratio of the sides next. So we're finding the inverse tangent. We're saying, what's that angle when the opposite side is 3, the adjacent side is 4? Well, you can tell right away that that's going to be a 3, 4, 5. So we don't even need to mess around and figure out what the angle is because we're not really concerned about the angle. We're actually saying, what's the cosine of that angle? So when we find the cosine, that's just going to be the adjacent over the opposite, so that's just going to equal 4 over 5. Over here, for sine of arc cosine of 2/3, same idea. We're trying to find that angle, and the arc cosine would be the adjacent over the hypotenuse, so that would leave this side as 9 minus 4, or just root 5. So we're not really preoccupied with the angle. We want to find the sine of the angle, which will just be root 5 over 3. Now let's look at the next one. Same idea, right? We're trying to find the angle. So the tangent of arc sine of x over 3. Again, it's opposite over hypotenuse. We have this restriction here because remember, we cannot have a domain value bigger than 1. So if we limit to 3, then it'll be less than 1. Okay, so the third side here, well, we just use Pythagorean theorem, so it'll be 9 minus x squared. And so the tangent of this angle, theta, would just be x over the square root of 9 minus x squared. Now let's consider the secant of arc tangent of x. Again, we're going to find this angle, well, not calculate specifically, but we have this is opposite over adjacent. So that leaves us with the hypotenuse will be x squared plus 1. And so if we wanted to find the secant of that angle, remember it's the hypotenuse over the adjacent, so it's going to be just x squared plus, could write it a little bit neater here. Let's write this neatly here. It's just going to be the square root of x squared plus 1. All right, for the last one, we have tangent of arc cosine of 2x. Again, it's arc cosine, that's the adjacent over the hypotenuse. And we want to find the tangent of that angle. Again, you can see this is restricted. So x can't be bigger than 1/2 because the domain can't be higher than 1. So if we consider the tangent, well, we need to figure out this other side, right? So that'll just be 1 minus the square of 2x, so that's just 4x squared. So the tangent will just be the square root of 1 minus 4x squared over 2x. Well, I hope this lesson was helpful, and I'll see you all in class.